Is the moon actually hollow? Are we really witnessing perfect solar eclipses by mere coincidence? What if I told you that what we think we know about the moon is filled with myths and mysteries that may surprise you? Today, we're diving into the facts and unraveling the science behind the moon. Stick around. You won't want to miss what we uncover. First up, let's address one of the wildest ideas out there. What if the moon is hollow? The theory that the moon might be hollow sounds straight out of a sci-fi movie, but it gained some serious traction after NASA's Apollo 12 mission. In a deliberate experiment, NASA crashed the ascent module from Apollo 12 into the lunar surface after the astronauts returned to the command module. Seismic instruments left on the moon recorded something truly bizarre. The moon vibrated and rang for a full hour like a bell. Imagine hitting a gong and it just kept ringing. That's what the seismic equipment picked up. Naturally, everyone was like, wait, is the moon hollow? After all, a hollow body would echo in a similar way. But hold on, before we go jumping to conclusions, let's look at what was actually found. There were 4 types of moonquakes: deep quakes, impact quakes, thermal quakes, and the most surprising, shallow quakes. Some of these shallow moonquakes measured up to 5.5 on the Richter scale, powerful enough to cause structural damage on Earth. But why does the moon seem to ring more than Earth? Unlike Earth, where seismic activity is absorbed by water and other materials, the moon is dry, rigid, and cool, almost like solid stone or metal. So when a quake hits, the vibrations reverberate for much longer, like a giant tuning fork. Could there be a metal-like structure beneath the surface causing this? Well, it's still a mystery, but if the moon were truly hollow, it wouldn't exert the gravitational pull it does on Earth's oceans, causing tides. Yet the mystery of why shallow moonquakes behave the way they do remains. Maybe one day, we'll send a mission to find out more. But for now, there's more we don't understand. And that's where things get really interesting. What if I told you that the moon's placement in the sky is so perfect, it almost seems intentional? Have you ever wondered why the moon fits just right over the sun during an eclipse? One of the most astonishing things about our moon is how perfectly it fits over the sun during a total solar eclipse. The sun is about 400 times larger than the moon, but it's also about 400 times farther away. That perfect ratio allows the moon to completely block out the sun's disk from our perspective on Earth, creating one of the most stunning natural spectacles, a total solar eclipse. But here's the thing, this alignment is incredibly rare. No other planet in our solar system has a moon or satellite capable of producing a total eclipse like this. If the moon were just a little bit farther away or a little bit smaller, it would only cover part of the sun, like in an annular eclipse. Here's something even stranger. We're living in a very specific window of time where total solar eclipses are possible. We know that the moon is moving 1.5 inches away from Earth every year. Millions of years ago, the moon was closer to Earth, and it would have blocked more than just the sun's disk. And millions of years from now, the moon will be farther away, meaning total solar eclipses will no longer happen. We'll only see annular eclipses where a ring of the sun remains visible. The odds of this perfect alignment happening during the time humans are around to witness it are astronomically small. This leads some to wonder if this is all just a cosmic coincidence, or could it be evidence of something more deliberate? Theories about ancient extraterrestrial involvement in our solar system have certainly gained traction, especially when you consider other oddities, like the placement of the Great Pyramids and the recent disclosure of UFOs by the military. Could it all be connected? The mysteries keep piling up. But before we dive deeper, let's talk about one of the biggest misconceptions about the moon, the so-called dark side. We've all heard it. The dark side of the moon is always in shadow, forever hidden from sunlight. But this is one myth that needs to be busted. In reality, the moon rotates on its axis, just like Earth does. However, the moon is tidally locked to Earth, which means it rotates at the same speed it revolves around our planet. As a result, the same side of the moon is always facing us. This is why we never see the far side of the moon from Earth. But that doesn't mean the other side is in perpetual darkness. The so-called dark side of the moon gets just as much sunlight as the side we see. It just depends on the moon's phase. Even though we now know the far side of the moon isn't shrouded in eternal night, it's still a place of great mystery. We didn't even get a glimpse of it until the Soviet Union's Luna 3 spacecraft took the first photos of it in 1959. And guess what? The far side looks completely different from the side facing Earth. Rougher terrain, more craters, and almost no large flat areas, known as lunar Maria. Could this tell us something about how the moon formed or what might lie beneath its surface? We're still figuring it out. While the far side of the moon is full of surprises, it's the moon's apparent size in our sky that plays a fascinating trick on our minds. Have you ever noticed it looks way bigger sometimes? You've probably noticed how massive the moon can look when it's just above the horizon, especially during a full moon. It can feel like it's looming much closer than it usually does. But is the moon actually closer at these moments? And also, from an outside perspective in space, seeing the actual size and distance of Earth and the moon seems illogical to compare to what you see on Earth under the atmosphere. This is known as the moon illusion, and it's a classic trick our brains play on us. When the moon is near the horizon, we compare it to objects in the foreground, like trees or buildings. These comparisons make the moon seem bigger, but in reality, it's still the same size and distance as when it's high in the sky. What's even stranger is that scientists still don't fully understand why the moon illusion happens. We know it has to do with the atmosphere partially, but some think it has to do with how our brains process distance and depth perception. Though there's no definitive answer yet, the moon may seem close, but what's really drawing us to go back there? The answer might surprise you. It's not just water we're after. While water on the moon has been a hot topic, it's not the only resource we're interested in. There's something even more valuable hiding in the moon's soil. Rare isotope could be the key to unlocking the future of clean energy. Helium-3 is almost non-existent on Earth, but it's been steadily accumulating on the moon's surface for billions of years, thanks to the solar wind. Unlike Earth, the moon has no atmosphere or magnetic field to deflect these charged particles, so they've embedded themselves into the lunar soil. The problem? It's incredibly sparse, found in tiny amounts in the upper few meters of the regolith. But why is helium-3 so important? It's thought to be an ideal fuel for nuclear fusion, a potential energy source that could provide virtually unlimited clean energy. Fusion using helium-3 wouldn't produce the dangerous radiation and waste associated with current nuclear reactors, making it a game changer for the future of energy. That's why so much interest has been directed at lunar missions, to harvest this incredibly valuable resource. The potential to power moon bases and even Earth using helium-3 might not be as far-fetched as it sounds. But before we dive too deep into the moon's hidden treasures, let's talk about how it controls something much closer to home: our tides. We've all seen it, the tides rolling in and out along the shore, seemingly moving the entire ocean. But here's the truth. The tides don't really come and go in the way you might think. Instead, the moon's gravitational pull creates two bulges of water, one on the side of Earth closest to the moon, and another on the far side. These bulges stay relatively still while the Earth rotates underneath them. So when you stand on the beach and watch the tide roll in, what you're actually seeing is the Earth rotating through these bulges, not the ocean itself moving across the planet. This explains why the oceans don't just blend together, because the water isn't traveling across the globe. Instead, it's Earth spinning inside the bulges. And now for our final mystery: why does the moon sometimes turn red, and especially in lunar eclipses? What's the science behind the appearance of a blood moon? It happens when Earth passes between the sun and the moon, casting a shadow over the lunar surface. But here's the twist. Earth's atmosphere scatters away the blue light, letting only red light pass through. This red light hits the moon and reflects back to us, giving it that eerie blood-red hue. It's the same process that makes sunsets look red, just on a much grander scale. So whether it's ringing like a bell or turning blood red, the moon never ceases to amaze us with its mysteries. From its perfect solar eclipses to the rare resources hidden beneath its surface, there's so much we've yet to uncover. If you enjoyed exploring these moon myths and facts, Be sure to subscribe and join us for more mind-blowing discoveries about the universe.